Today is the last day of notes. Congratulations on making it through.
That means we have to do the homework. That means that we have to take the test. That means that we have to do AP physics.
You get tested on one chapter, right?
Yes, this is the only chapter that you'll be tested on for this section, so that's good anyway. I have a question for today, and again, you don't have to write these down, but think about it and consider. A ball rolls perfectly down an incline. A box of the same mass slides down the same incline, now frictionless. Which reaches the bottom first?
Both are frictionless?
Both? Well, no, the one that rolls does have friction, otherwise it wouldn't roll. But then when the box slides down, it is frictionless.
The ball, because it can build up momentum more.
Okay, so I have how many votes for the rolling ball? How many votes for the sliding box? Okay. The sliding box is correct, and you'll find out why at the end of class today. So, actually, well, friction is partly to blame, but not in the way you would think.
Because boxes are actually faster and have more air.
Also friction. Yeah.
I'm borrowing writing utensil. I'm borrowing writing utensil.
Work and energy in rotational motion is where we're going to be going today.
What if I wanted to stay at the bus stop?
You can't. You're going to be picked up by the physics bus, whether you like it or not.
Isn't that kidnapping, and I could sue the physics bus driver for kidnapping me off the street when I just wanted to stay at the bus stop?
No.
First of all, I don't think you would sue your kidnapper. You will file charges against him, right?
I suppose so. But because this is AP Physics, and I am like
I am the physics.
I am the benevolent dictator of AP Physics, so I get to set my own laws, and kidnapping is allowed here.
Oh God, you said that on camera.
I've said a lot of things on camera that I would... Actually, no, I would not take it back. It makes it more fun. We're all having a good time here.
Oh no.
Mr. Hathaway,
Okay.
your career is ruined.
As soon as somebody watches these videos, oh no.
Yeah, that's probably going to be it.
Hi, Kylie and Potter.
Hi!
Okay, so work
Get in the bag.
Do it.
is equal to change in kinetic energy.
If someone responds that they don't want to get in the bag or they don't want to get kidnapped, can we get extra credit?
No.
What if they say you do want to get in the bag? If they say they do want to get in the bag, you can them.
Okay, let's not take it too far here.
He's getting scared.
So work is equal to... If I don't reel you guys in, sometimes I wonder where you'd end up.
We have creative imagination.
I know you do.
That hurts. We need to stop.
If you weren't here, I'd vote Placido's dictator.
Okay.
Not like my vote would matter if it was a dictator.
So obviously, change in kinetic energy is 1/2 mv squared. So that would be 1/2 mv final squared minus 1/2 mv original squared. We dealt with that in the energy and work section. For rotational kinetic energy, it would be 1/2 I omega squared minus 1/2 I omega original squared.
Oh.
So that's not too bad.
Nah.
Not yet, anyway. I want to be able to lock this door from the inside. I think that'd be fun. Because then you'd really be kidnapped automatically.
Wait, but then we'd be able to unlock something.
I'll figure something out.
It's all fun and games until he actually does it.
Aren't there two ways?
I bet you Ben could like squeeze
Cut
under
the
the
doors
door.
off. What?
Okay.
Halfway inside.
Maybe through the window.
You gotta be pretty thin to get through that thing.
Oh, I can get.
Oh yeah, I bet you could.
You can get through the bars on like a railing? Mr. Nichols sounds like yeah.
So,
Yeah, it was a whole ordeal.
rotational
If we did get kidnapped, I say we just play game.
rotational kinetic energy and whatnot. So,
I say we make a band.
He's get bored of us eventually.
Look, he's drawing a picture.
Oh,
this is a
that's
ball.
picture.
And it is rolling. It is rolling clockwise.
Is it a rolling stone?
No, it is not a stone. It is a sphere.
The rolling stone.
And it has a mass, M.
I really enjoyed that. One more time. What is it?
It is a sphere. What are you laughing about?
Test yesterday and it's not going well.
I know.
So if this ball is rolling, it has kinetic energy. Nobody disputes that. But what we have to take into consideration now, because this is AP Physics, is that the spinning motion itself has kinetic energy. The fact that it's spinning is energy in and of itself. And so when we're dealing with this in terms of energy and energy transfer, we got to see how this is going to affect our problems if, like, we're starting up here with potential energy, and now that potential energy is not just transferring to kinetic, but it's split between regular straight line motion kinetic and spinning kinetic. So, you'll see exactly what I mean shortly here.
I really want to leave.
Sorry, you're kidnapped.
I mean, you could.
So,
I've never wanted to leave physics before, and this.
oh come on, this is an easy day compared with what you've done already, believe me.
Sometimes they're bad.
Yeah,
Yeah.
remember as the week goes on, our mental capabilities go.
So,
Hop on the trampoline over the weekend and then go back up.
Now let's just talk
Okay.
about olive oil.
here we go. Eyes up here, folks. So, when we're dealing with this straight line motion and straight line acceleration, we're talking about it in terms of the object's center of mass. So if we're looking for this velocity, what I'm really asking for is how fast the middle of this object is moving. You can probably guess I'm not going to be concerned about what's the velocity here or here or here, because that's going to be very difficult and not something that we want to concern ourselves with right now.
Pretty straight line.
There they are.
Sorry.
So yeah, this velocity, and if you deal with an acceleration, is in terms of the object's center of mass. Because, like, if we took the acceleration of this point, it's changing all the time, because it's changing direction. Okay. So yeah, just wanted to mention that.
We don't have to worry about lollipops right now, right?
You always have to worry about lollipops. Are you kidding me?
That was a dumb question. That was a dumb question.
Oh,
I'll be honest.
wait, so
It's not really a dumb question. That was a dumb
yesterday
question.
how we said the center of mass isn't always in the half, like that's what I meant. I thought you were like lollipop.
Oh, I thought you were. I thought that was just out of the blue.
Huh. I know.
That makes it so much better. I'll be quiet.
Draw this.
That is actually a liquid. You should change the pH to a
Pretty much.
Which class do you hate? Solid silver?
All of them.
Or this?
Mr.
All of
Honeywell,
them.
Yes, Plessy.
Tell me, like, there's an AP physics question in front of you. If you do not get at least 6 points of partial credit, the gas will be released. You have 10 minutes.
Nice.
If Mr.
I like that. That's like your
What's
final.
that movie called?
Nothing.
Jigsaw.
He's
Saw.
Jigsaw.
You're like the Saw guy.
Oh my gosh.
Except instead of trying to kill us, you just make it
We break him.
physics or death, and every time you get like partial credit, you move on to the next room.
I should have known that rotational motion would end here with you guys comparing me to the villain from Saw.
Wait, so
It's a
the
good
movie
movie.
is called Saw, and the villain is Jigsaw. Is the movie about the villain? Yes.
Well, I think he's. I've never actually seen it.
So the purpose of Jigsaw is it's like a jigsaw puzzle that they have to figure out.
Okay.
But the
Bad people, and he makes them. He says that-
Caitlin, do I remind you of Jigsaw? Do I remind you of him? I didn't think so. I thought I'm pretty adorable.
Well, Jigsaw's doll is too.
That's how they always start off.
Okay.
Oh, you're like the villain from Toy
Stop!
Story.
No.
Where you're
Stop.
very cuddly, but you say
Matzo?
evil things.
Oh my gosh.
I can't handle her.
I'm not getting matzo vibes. That'd be like short, stubby people. You're not really short and stubby.
Okay.
See, sometimes it's
Okay,
real
let's
science.
focus, guys.
How can we start talking about babies?
So, that's a question. And we got to figure some things out about this question. So, you've got the solid sphere here. This sphere is rope. I totally meant to do that. And my foot is totally not hurting right now.
That demonstrated the motion of the sphere as it
I
went
can
down
still see it on your.
Y'all, I think that's just scratch it.
I mean, you're right.
I got to go to the basement to
Mr.
get an ice
Hathaway, I
pack.
hope you have a great day today.
Thank you.
Mr. Hathaway, are we just gonna scratch
What
it?
is
What's happening?
You went to get an ice pack. Be quiet. Can you get a baby candle?
Oh, he's back.
There we go. Phew, that's better.
Wait, you didn't bring the board back. Did you take
I didn't bring the what back?
the board?
Ugh, I'm going to use the elevator this time.
I'm genuinely curious what's happening right now. Are you just Katie, stop laughing. Oh no, it's stuck.
Oh no, Mr. Hathaway's trapped.
Wait,
There we go.
how did you do that?
Jaden,
Wait, do it again. I don't believe it.
Did you just do the splits or like did you?
No, I was kneeling.
Okay. How did you move so? What?
Okay, so
I have a feeling we're going to remember this day for a long time.
it's never that serious.
We're going to be like,
It was amusing.
remember what rotational motion did to us? Oh my goodness.
No, but remember
We pull up the video.
Oh, and this is going to be out there forever.
How far into our lesson
Thankfully, you
are
don't
we?
have to post the video.
This is I'm going to post it. This is a one and done thing.
Yeah.
Solid sphere. That's a sphere. It's rolling down the incline there. Mass m, radius r. X is the total distance it has traveled. Y is the height that it begins at. And our goal here is to figure out both its straight line velocity and its acceleration. So, let's do that. You'll notice there are no numbers. You're welcome. Okay. So, hopefully you realize that we should probably do something with energy here.
What?
Hopefully you realize that we should probably do something with energy here.
Hopefully.
So, what kind of energy is there at the beginning?
Potential.
Yep.
MGY.
What's there at the end?
Kinetic. MGY.
In addition to regular kinetic, what other kind of kinetic is there?
Spring.
Yeah, rotational kinetic.
I like how we all said spinny. Spinny and
I
spring.
tried to
That was
guess
the
it.
one.
I totally said spring.
Yeah, Enderhead.
That
Enderhead.
was the only other one I knew.
Aw, funny.
That's just what the day's about. At least it's a good struggle, though. Not like a calc struggle.
Oh wait, hold on. Mr. Hathaway,
Yes.
would EO equal E total?
Yes, it would.
Okay.
Really had to think about what hope meant.
Now, a couple things about this. If we're solving for velocity, we want to get this v all by itself, but before we do all that work, pun intended, there's a couple things that we need to take care of here.
Can we put the I and W with the R?
What, with this R?
Yeah, well,
No, it's just the
how
subscript.
rotational
Oh, with, yes.
equals- yeah.
Yep, that's what's coming next. So this is a solid sphere, and the moment of inertia of a solid sphere is equal to 2/5 mr squared. And you can find that on page 286. Solid sphere,
I feel like
We need to remember.
right there.
it'll be given to us in problems.
Yeah. Well, I mean, like on the worksheet and everything, you got to turn to this page to figure it out. So you might want to write down 286 somewhere.
I'm gonna see it and have no clue what it's for.
And also, where did I get it from? It's the results of a sophisticated calculation. So omega is equal to V over R. So that way I can get rid of this omega and change that into, the V there.
Are we solving in the room
We're on the
today?
virtual
No,
Oh wait, no, we're not solving in the room.
Yeah,
Oh,
when you're solving in
guys.
the room, we would have
Guys.
I.
I was driving down 76. And it was like, what's that church
just
down
get
by
rid of it,
Oh yeah, we can get rid of
Yes.
everything here.
Like,
This is the most fun.
Oh, and
Yes,
the
it is.
Yeah.
Our shepherd.
Dude, our shepherd has a Jesus fish on their building. Did you guys
Yes.
know? That's crazy. I did
There's
not know
like a
that.
big cross.
They have a Jesus fish on the building.
Yeah.
That's insane. Is that what you
Yeah,
guys
they
got?
must
Jesus
really
fish
love
on?
physics.
No. Am I just slow?
Yeah, he's
Okay.
This is Jesus.
Guys, I don't know that. I've never seen it simple before.
Really?
It originally came from like being a secret message between Christians.
I didn't know that.
All right.
I didn't know that, guys. I saw Jesus fish on the building and I was like,
Physics.
physics.
So when you look at this, you should get pretty excited because there is so much that we can just get rid of. Goodbye,
I'm
Emma.
ecstatic.
I was totally about
Let's see. Goodbye, R.
Yeah. Get
Come
out
on.
of here.
Oh,
Take that, pirates.
Come on, rattlesnake.
I think that's it for now.
Oh. Rattlesnake.
1/2. 2/5 times 1/2 is 2/10, which is 1/5. B squared.
Oh, it's already so pretty.
Yeah. So now we got to do the least common denominator multiple thingy. So I think that's 10, right?
Yeah.
So that's like 2/10 plus 5/10. So that's 7/10.
Yay. Yeah.
Hey, that's how much Dogecoin is worth when I sold all 11,000 of mine.
Didn't they like halt the bottom of it or
That's something else.
So then, to finally isolate your velocity, divide both sides by 7/10, and then take the square root.
So square root of 10 7 is G1.
You got it.
Yeah.
And that is our velocity.
Mr. Hathaway, I'm gonna be real with you.
something?
Yes.
Sometimes you be forcing it sometimes.
How?
Nice.
Oh.
I wasn't even thinking of the pun.
Oh.
I'm just saying you're forcing it sometimes.
Sadly, I'm gonna be honest. I really enjoyed this class.
Oh, good.
I highly
Did you
recommend
enjoy my dad jokes on my virtual day assignment?
Oh, yeah.
it. Wait, is that the
Personally, I
like
thought
physics
my
cop
poop
thing?
jokes were
Huh?
bad.
Did you start at the end of the physics cop?
Yep.
Nice.
That was sweet. I really enjoyed reading your comments on that. That was hilarious.
Fast and Furious one. I was like, if you're gonna steal $1 million, you might, or however much money, like, you might as well just do it right. Like,
Exactly.
there's a right way to steal $1 million, and there's a wrong
Okay,
way.
but who's actually seen the movie?
Yeah.
That's a great movie.
I don't know that I've seen any of the
The
movies.
Fast and Furious one?
Fast and Furious is those are great movies.
What movies were in the train?
Fast and Furious.
Indiana Jones was in there.
I see these.
I don't remember.
The the
Not Indiana
space
Jones.
ones.
Yeah.
Oh, I might have seen that one.
Really? I don't know who it's like.
Because my dad likes this.
Oh,
space
true.
one. There's the maybe one or two that I've seen.
Now, again, when we calculated that velocity, what we're finding is the velocity of the center of mass of this solid sphere. So we've got one more thing to do, and then we're finished with rotational motion notes. And that is, we got to find the acceleration of this solid sphere. And the place we're going to turn to that brings us all the way back in a beautiful circle to basically the beginning of AP Physics.
Remember when we were in normal physics and all we had to do was draw lines from the sun
Oh.
and say where they would go?
Timeless velocity.
That was.
Those were the days. Where would the shade be?
Oh yeah. Or let's
And
start
then
a
Did they have
fire.
the shade?
Let's
shade.
start a
There was like the
fire.
dark shade and the light
Yeah.
shade. Oh, those were the
Day
days.
one physics right there. Draw
Oh,
shadows.
Remember with the lenses
Wait,
that
what
we
are
got
we
to
solving
start a
for?
fire?
Solve for acceleration.
Oh, this is not that hard, actually.
Nope. So let's isolate the A. But before we isolate the A, let's just make a few things known here. So change in x is final x minus original x. And, we're starting at the 0 point. So we could just say that this is x instead of change in x here. And original velocity is 0. It's just being released from rest up there. So therefore,
S.
let's see.
2x or not 2x?
C squared equals X.
However,
Taxation without representation.
there is a way that we can make this a little bit more specific. We calculated our velocity in the last one, right?
Yes, for you.
Oh, why?
So that was what? G.
10
10
square root of 10
over,
sevenths
radical
is
10
y.
over 7.
But if it's squared, you don't have to.
Right. So that's 10/7 GY. You know what I wonder? I wonder if there's a way that we can get rid of this X, get it in terms of Y, and make it even more simplified.
That's not
Huh?
You can just change it.
It's
Huh?
not simpler. That's
Just
not
change it?
simpler.
Yeah, just erase the bottom right.
The extra stick.
So,
Add the stick or erase the stick.
You know what they say, Mr.
I desperately want the time when we say, oh, just erase this and you're good, and he actually does. I desperately want that. Just,
There we go.
There you go. Don't do anything else. Class over.
Yeah, but they can be changed in y originally. You can
Okay.
set it equal to change in y. So technically, that's right.
what?
But
Oh, that's a vertical thing, though. We're treating this in terms of the X direction, which would be this right here.
never before have I heard it just
Okay.
what?
So, may I draw your attention to Exhibit S?
Oh, we have a stupid.
You can just do
B.
We have a triangle.
No, we have a
Oh
angle.
wait, you can do sine theta.
Thank you, Placido.
I said trigonometry.
We can use sine.
I said angle thing.
Hypothetically. Mr. Hadley.
What's that?
You haven't changed colors yet.
Oh, I better change
Eventually,
that.
eventually. Yeah.
Red.
Not yet. No.
Red, okay.
He says bye.
So sine theta is opposite over hypotenuse. Opposite is this. Hypotenuse is that. So sine of theta is y over x.
We're solving for x.
Yeah, we want to solve for x so that we can get rid of this and maybe even get rid of some of the y's then. So yeah, y over sine theta. So therefore, let's just rewrite this here first before we do any more work. So 10/7 over 2. All right. So,
I really don't.
well, you can tell that the y's are going to get canceled out. So that's good. And let's see here. This 2 would combine with this 7 to make 14. Actually, I'm going to do this a little bit. Yeah, good idea. So it's like times, and then we inverse this when we multiply.
Wait, don't you need to square that?
We did already because it was originally square root of 10/7 GY.
Yeah. So that's where we are. Let's finish with blue.
You're just making us up there.
So 2 and 7, yes. It's okay, I don't go down to the basement too much anyway. So 2 times 7 is 14.
That's just where the company says.
10 over 14 is like 5 over 7. G
That's where the company stays.
sine theta. Woohoo! Woohoo! Indeed.
No, it's Yahoo.
Oh, that's right.
Woo!
Yahoo!
What the noise Yoshi makes?
No, it's Mario.
Yahoo!
Oh, from like
More of a W.
Yahoo!
whenever I hear Yahoo, I think of Mario Kart. Yahoo!
That's Mario though.
Yeah. So 5/7 G sine theta. So
I stopped writing along.
that is our acceleration, and once again, that is the acceleration of this object's center of mass, the straight line acceleration it experiences as it goes down this incline. Yes.
Does this work for all solid spheres?
Yes.
Or work for a cone.
Let's go.
Or work for a cone.
For a cone? No.
What about a lollipop?
No more talk about lollipops.
Hypothetically, if the
Wait, no, we're so close to being done.
So, here's the end now. So, if this object was just sliding down this incline, all of the potential energy would go to translational or straight line kinetic energy, like if it was sliding. So it would have a larger velocity at the bottom. But because that potential energy is divided between the actual rotational kinetic energy and the straight line motion kinetic energy, now it's not moving as quickly because some of that energy goes into making the thing roll in the first place. So, in answer to the question at the beginning, the box that's sliding on the frictionless surface would get down there first because all of that energy goes into straight line motion. Whew. And that's rotational energy and rotational motion.
Basically, I already knew all this before we started. That's why.
Now, I know this has been a lot of material. I just want to share a couple things to just kind of bring this all together. Remember, torque is huge in this section. You need to make sure that you're aware of all the different things that torque is equal to. And that is mostly all on your formula sheet. So make sure to have that handy as you're doing the homework. Also with torque, in order to solve for rotational problems that are trying to, something holding still, and you're trying to figure out things about that particular scenario, you have to take your torque going clockwise and your torque going counterclockwise and use the difference between those two things in order to solve for the problem. Counterclockwise would be the positive direction. Counterclockwise would be the negative direction.
So clockwise is negative, counterclockwise is positive. You said counterclockwise for both ones.
Oh, I did. Counterclockwise positive, clockwise negative.
There you go.
Are
we distracting you?
Been distracting me all school year.
Y'all, we gotta just restart the day.
And then in terms of angular momentum is something where when something is spinning, the fact that the momentum is conserved is going to cause that object to spin faster or slower based on what you do with the radius. If the radius goes up, then it's going to slow down. If it gets smaller, then your angular speed is going to grow for those reasons. So, what else? Anything? Yeah, just keep an eye on rotational kinetic energy. But yeah, so don't forget about some of the big picture things with this. Even though we've been going over lots and lots of particular scenarios, it can be pretty complex. Be sure that you can stand back and kind of see what's going on overall. Questions? Yes?
What are your opinions on Megan Thee Stallion?
And that's where we're going to end.
So, you're not